This is a Radical Exchange production. Hello, and welcome to Radical Exchanges. In this episode, Matt Prewitt is joined by Zhexi Zhang to discuss his latest piece in Combinations, titled The Critical Legacy of Chinese Cybernetics. They explore the origins of cybernetics, its adaptation in China, and the pivotal role of figures like Qian Xuesen. They discuss the unique cultural and political context that shaped Chinese cybernetics, and examine its far-reaching impact on various disciplines, including artificial intelligence, computer science, and the social sciences. Combinations is a new publication of Radical Exchange Foundation, exploring new ideas about economics, democracy, and the relationship between technology and power. Our aim is to illuminate new possible paths for present institutions, spotlighting the connections between ideas, technologies, and social and political organization. And now, here's Matt Prewitt and Zhexi Zhang.
Gary, great to see you.
Hey, Matt.
I wonder if you can maybe take a moment by introducing yourself and your work to the audience.
Hi, yeah, my name is Zhexi Zhang. I'm an artist and writer on the art side of things. I'm mostly make films, installations, various kind of more like site-specific conceptual works, and also work quite a lot with technologists and in the kind of context of institution building and this kind of thing. And as a writer, I guess I've covered a lot of things, but my own interests and my own research are mostly within aspects of history of science and technology, and including kind of conceptual histories of post-20th century kind of ideas, systems ideas predominantly, such as ecology, such as cybernetics, these kinds of spirits of what Adam Smith called, I think, the spirit of system, this idea that's like a certain ontological key could unlock a whole set of currencies and a whole universe, like a law of like a scientific law or something would open up. I'm kind of both interested in how those systems come about and how they work, and also just the desire and the historical context and the personal psychological kind of context that bring those about in certain individuals.
Super. You have written a great piece for the first issue of Combinations. It's about the history of Chinese cybernetics and how that has sort of dovetailed with the history of Western cybernetics, a la Norbert Wiener, and sort of other factors in the history of the 20th century. But I wonder if we could start off by you just saying a little bit about what got you interested in cybernetics. Is it something that plays into your work, or something that you've just come to by other intellectual avenues?
Yeah, I think the short version of the story is at some point, barely maybe a decade ago now, I kind of came into contact with information theory as an idea in its own history, and that kind of, I spent quite a long time quite obsessed with this conceptual shift from, I guess, the thermodynamic to the informatic as kind of these different, almost like epistemic eras for thinking about scientific reality in some ways. And then that very quickly led to...
Sorry, if I could pause you, could you say a little bit more about that? So what's the difference between the thermodynamic and the informatic?
I mean, I think from a cultural point of view, like outside of the actual nature of like Boltzmann and Shannon and these various figures who came up with the formula that find these eras, from a cultural point of view, I was kind of more interested in how, let's say in the 19th century, with the likes of Freud and others, we had a very strong metaphor of the human and the mind and the brain as a kind of set of heat engines, like pumps and pressures and various kinds of those kinds of dynamic systems taking place. And then come into the kind of more quote unquote machinic era, coming into there's a longer history, but obviously centering on World War II in the 40s, with the likes of Bell Labs, MIT, the kind of cybernetic crew that we're probably about to talk about. You enter into this different kind of paradigm as a currency for understanding various kinds of systems. And to a point, I guess I'm quite interested in how those metaphors continue and linger and intermix over periods of time. And we still think of psychiatry, let's say, as a sort of system of pressures to some great extent. And, people like Philip Mirowski, for example, has done really interesting work on how economics borrowed all of its ideas at the time from physics of the 19th century. And when physics updated itself, economics didn't bother. It just kept on its utility functions mapped to like the energy like formula of like 19th century thermodynamics, for instance. And so, yeah, I'm kind of interested in how these things become socially operative, remain scientifically operative, and also come into how we design and build systems. That and the fact that this kind of slippage between thermodynamic and informational entropy has always kind of intrigued and eluded me a little bit. I mean, it's kind of a direct reappropriation of an entropy formula by Shannon of like Boltzmann and so on, but at the same time, it's kind of a metaphor. I feel like you go into a very crazy headspace when you try to actually form a kind of direct continuity between those two styles of entropy. But it's kind of fascinating to me. Yeah,
that's interesting to me too. What strikes me is that, I mean, when I try to imagine the ideas that you just described, like basically it's a movement from one kind of a control system to another, right? I mean, so you can think of engines and pistons and thermodynamics in that regard as like the basis of systems of control. And then cybernetics, the word itself was, is based on the idea of a steering system or a control system, but it's using information as the means of controlling the system instead of, let's say, pressure and heat. What do you think about that? Is it just sort of a shift from one medium to another, or is there some qualitative change there?
I feel like I'm going to try. I don't think I'm strong enough on the history here, but I feel like this hinges on how we thought about control as part of a system between these two paradigms. I feel like in the kind of post-information paradigm, we have an idea of control, which is almost self-evident and automatic. Like if there is system, there is control. Mm-hmm. Whereas in the kind of prior thermodynamic style, you had something that was like all systems are fundamentally dissipative, and like you kind of you're trying to like retain and hold on to and like take like to kind of marshal that kind of heat energy how you can. But I feel like you don't have this kind of idea of the feedback loop as strongly, at least. I'm sure someone's going to correct me on this, but like I feel like when you come into cybernetics, like 19th century French. He was a hydrologist or something. 18th century French. So the idea of steering as how to marshal a system, yes, but I think it's only a bit later into the kind of mathematic paradigm that you get this idea of control as a kind of self-automating, like self-correcting feedback loop. That if you have a system like a cell or a homeostat or something, it is fundamentally already doing control by virtue of existing and not ceasing to exist. If that makes sense.
Interesting. So the original, like, I'm not sure what the right vocabulary was, but the original like engine governor technology was this thing where like you've got a traditional thermodynamic internal combustion engine which spins, and then it's got like a weight attached to it on a chain. Mm. And so the idea being that as the thing spins faster, the chain kind of starts to go horizontal because of sort of centrifugal force. And as it goes more horizontal, it creates more resistance on the spinning engine. So it prevents the engine from spinning too fast. And so that's totally thermodynamic, right? And that does seem like already the idea of a feedback loop is implicit in that, although I'm sure it's not formulated as precisely as the later cyberneticists did. But does that make sense? So
no, totally. Sorry, no. I actually haven't seen that. That is a really great image. No, I think you're right, and I think once we look back, like if we keep going back to the history of like water clocks and all sorts of other mechanisms, we see like kind of maybe very different paradigms of like control that are happening. I'm trying to think what the difference is. I feel like it's the difference between like into information theory is that you have an idea of a system that's totally contained within a set of possibilities, like binary code or something, or within with the probability space. Your entropy is contained within the probability space that is kind of already to some extent like contained, understood, or defined by whatever system whatever language you're in. Like all those ideas about the entropy of the English language, for example. Like Shannon has a great paper on crosswords about how like English is really good for crosswords because it has about a 50% redundancy rate, which means that you can actually do a crossword to a satisfying degree, and it's not just like swimming in noise or something, or really obvious.
Yeah, totally. I mean, and there's a slightly orthogonal point here, which is just interesting that I want to point out, and then we can loop back from it, which is that like that in the just in the sort of ideological realm, people have a very different way of thinking about information than they do about sort of, thermodynamics and engines and, explosions and stuff, right? And the main difference there, I think, is that this may not always be the case, but in many cases, people have an idea of information as being somehow sort of non-coercive or bloodless, right? So there's therefore some kind of contradiction in the idea of, or some kind of apparent tension in thinking about it as a control mechanism, because, especially perhaps in the American context where we think, I don't know, words, sticks and stones can break my bones, but words cannot hurt me, sort of a thing.
It's almost like a distinction people like to make between information and knowledge, or something like what is something that's usable and understood, and something that's just there for you in a neutral way.
Exactly. So there's something a little bit counterintuitive from a certain point of view about information as a means of control, whereas I think thermodynamic control somehow feels more, I don't know, less surprising or something. And I think that kind of apparent contradiction in the idea of informational control has actually been really important particularly in the second half of the 20th century, as you've seen sort of ideologies presenting information systems as inherently liberatory, for example.
Yeah, no, that's a really big one. I mean, which is interesting, like, just to follow your thing, in the original paper, like, of a mathematical theory of communication, the model of communication is pure control. It's not about communication as such. The point of communication is for person A to compel person B to do the thing that they're trying to make them do, right? It's not even about like, can we pass on this message as such? The message has a purpose. If your communication does not like change behavior, I think Warren Weaver's introduction actually maybe talks about behavioral change in like the other party. So it's kind of neatly at the heart of all of these things as well.
Yeah, totally. I mean, the idea of control is very much there in the mid-century cyberneticists, but it somehow turns into something else by the time you get to like a 1984 Apple ad or something, right?
I was thinking exactly that. I mean, I feel like the classic kind of A/B is like the IBM man and the Apple, like a 1984 ad. Yeah, like one is like a total drone, and the other is like a whole symbol of like sexual and sort of personal liberation.
Right. Great. So now, before we get to the history of cybernetics in China, what are your thoughts on the sort of contributions of the initial cyberneticists? Like, are you a fan of Norbert Wiener, for example? How do you relate to these ideas?
I mean, I don't know if anyone could, on some sense, not be a fan of Norbert Wiener. I mean, I was fortunate to spend some time at MIT, and when I was there, I did spend some time in his archives, and I have these pictures on my phone of his drawings of tortoise brains when he was 12. Like he was a fastidious self-archiver who I think was such a child prodigy that he realized that he was important by the time he was about 14 and started like, he did his first, I think, biology or something degree when he was about 14 at Tufts. And yeah, I mean, he's a thoroughly, well, weird, sympathetic, very moral and ultimately quite likable figure, I think, and obviously a complete like genius in every sense of that. Although in a slightly smug, self-aware sense, but nonetheless, I guess he gets the kind of genius card. Yeah, I mean that stuff is, I think, is the fact that he came from is that, like, I think research in Brownian motion and like where the kind of Wiener functions and stuff come from, and like ended up in cybernetics is kind of fascinating to me. The way he went from a kind of mathematical space to this much broader sort of post-war, very kind of nuanced sort of liberal imagination through and quite, he was quite anxious as well, I suppose. In even in like the 1960 book, I think he's ultimately like very anxious about the state of the world, and he stops taking funding from the DoD, I think, at some point during the Cold War. Yeah, I think he's a thoroughly sympathetic figure, but to the extent that he is the founder of cybernetics, it's also kind of interesting to like whether they are the first cyberneticists, if that's meaningful or not. He certainly was a great figurehead who gave it the term. I think there was like some debate also around his like his work's kind of parallelness with Kolmogorov, I think. And there was like interesting stuff happening with control systems theory, and at least in Russia at the same time. And what's kind of interesting about someone like Qian Xuesen, the Chinese cyberneticist that ends up writing about, is that it's not very clear how directly inspired by Wiener he was. He certainly took Wiener's term and like really went with it, was highly inspired by him. But by that point, by the 1950s, he had also spent about 20 odd years at least, maybe 30 years as a kind of control systems engineer, rocket scientist person. So he was really, in a way, writing a textbook, kind of at that point, for some people, the textbook on how to make ICBMs not wobble under various conditions, and how to control mostly projectiles in very like turbulent and unpredictable conditions, and how to correct various forms of physical forces and so on. So there's a kind of mishmash going on, I think, in those early years. But then if you follow the kind of Norbert Wiener cybernetics trajectory, which is by far the richest and the most interesting, there are lots of these alter cybernetics, but none is as kind of well covered, and also as deep as the Western one ultimately. You do get into this fascinating area where it became applicable to almost everything, was inspiring to anthropologists like Bateson and Mead, was the center of these kind of moments of grand interdisciplinary dialogue that we often still look back to now, like the Macy conferences, which in themselves were mostly just people not seeing eye to eye and kind of really disagreeing with each other and probably coming out kind of furious. Like these were, I feel like we tend to lionize these kind of past meetings where often they were just like academics bickering, but they were nonetheless important and were significant meetings of different fields at the time.
And these were mid-century, like around 1950 conferences at which the discipline of cybernetics was first sort of named and articulated.
Exactly. Yes. Sorry. So you have people like Warren McCulloch coming from neuroscience, people like Gregory Bateson and Margaret Mead coming from anthropology, cultural anthropology. and various engineers. I think people like Shannon, who was very against all of this, to be honest. I think he wrote a book called, an article called The Bandwagon, basically saying everyone stop joining the bandwagon of information theory. This is, a pure theory about noise and information on communication lines, and not a metaphor for absolutely everything else. But then, of course, that kind of did rapidly diffuse into hippie culture, into various kinds of liberal ideologies. And I guess at some points, it sort of also traded places with AI. I think someone else I don't know this history well enough, but I believe there was a kind of actual moment of kind of a branding thing with like the likes of Minsky, where they basically chose to go with artificial intelligence as the name for how to create essentially neural networks that were initially pioneered by Walter Pitts and Warren McCulloch of the Macy conferences to think about kind of artificial minds rather than cybernetics, which was this much baggier term at the time. And then by the 80s and 90s, you basically don't have it anymore. Like there's no one is really talking about cybernetics, and there's like one department in England that's still somehow pushing it as a real field.
Yeah,
so I mean, it's a fascinating story.
Yeah, I think that continuity is really important to see between how cybernetics sort of becomes artificial intelligence. In your piece, you focus a lot on a particular figure from China who became an important thinker in this stream. You already mentioned him briefly, but I wonder if you can say a little bit about who this is and what makes him important.
Yeah, so this guy is called Qian Xuesen. He was, I think, born at the very end of the 19th century, if I'm not mistaken, and came from quite an aristocratic family in Shanghai. And in China, his name is well known because he is pretty much the father of modern Chinese science in some ways, like the kind of only sort of heroic scientific figure going for certainly of the post 1950 period in China, the one that like has like a museum dedicated to him and this kind of thing. He's less well known outside of China, perhaps, and maybe mostly known as the progenitor of Chinese cybernetics. Or if you're if you're kind of nerdy about the history of NASA and this kind of thing, he was one of the founding members, or one of the founders of the Jet Propulsion Lab, the JPL, which preceded NASA itself as an organization, as a place to do kind of rocketry research. So I guess to give a little bit of background on him, he was from an elite family and born into, had his formative years in Shanghai, I think after the revolution, like in the kind of Republican period. And after the Boxer Rebellion in the 1910s, I believe, or maybe a little earlier, the American government gave a lot of scholarships as a kind of, I guess, cultural diplomacy deal to Chinese students to go and study in the US. And this actually produced quite a number of significant figures who later came back to China. And Qian was one of the ones who went to, I think he initially went to MIT and ended up under the tutelage of Theodor von Karman, who's a Hungarian rocket scientist, like one of the sort of founding figures in that field in the 20th century. And then as kind of one of von Karman's top students, went with him over to Caltech and later became very much part of this kind of Californian world. I mean, I think he was actually, he was like attending the parties of Robert Oppenheimer's younger brother, who also briefly appears in the movie as the kind of main Marxist communist link. Yeah. Ironically, Qian in this time, while not unsympathetic to Chinese communism or to the kind of like whatever would be the fate of China, he was ultimately kind of patriotic but he wasn't political by any account. He's kind of a quiet figure lingered at the back of these parties. But then there was this, he gets kind of loosely linked early on to these kind of more like at the time communist agitators in the 1930s who would then get like screwed over by the Red Scare, along with Qian himself.
Sidebar, Oppenheimer's brother is also the founder of the Exploratorium in San Francisco, if anyone knows that place.
Yeah, wow. Yeah, well, okay. So this is, I mean, there are lots of fun legacies here as a kind of sidebar, it's part of Qian's story. So Qian becomes, when he's in this kind of cozy academic scientist Caltech crowd, he's mostly, I think, just being a kind of expat American scientist, basically, at this point. And he becomes part of the small crew under von Karman of like rocketry researchers that become known as the Suicide Squad. And each of them are quite interesting. I'm trying to remember if I can remember all of them now. The most famous one is Jack Parsons, because he was, long and short, he was a sort of Satanist. He was a follower of Crowley or another kind of school of this. And he did a lot of rituals. And I think no one's quite sure what happened to his wife. He had a very kind of colorful life, and another one closer to the exploratorium side of things is Frank Molina, who I think is actually the founder of Leonardo Journal, which is a very well-known journal if you're in the kind of like legacy art and tech kind of world, the kind of electronic kind of art, science, and technology kind of space. And there is another member, but I suddenly can't remember their name. But the Suicide Squads are kind of well known for basically going into the deserts in Pasadena and like blowing stuff up as part of their experiments and becoming the kind of top rocket scientists in the country and therefore probably in the world at that time. And so what's notable about this kind of, early, I can't remember exactly what age he was, but I guess he was in his 30s and 40s before the war. He became one of the top scientists of America, really, I think, in terms of this particular field of rocketry ballistics, and which then became extremely important during the war. And then I think just after the war in 1945, it's kind of extraordinary to consider this, given what's happened to him after, and then what China-American relations since. But after the war, he's given like top military clearance and is like is made a colonel of the U.S. Army so that he can go to Germany and inspect German science. And yeah, I think I wrote about it briefly, but there's this picture there from his European visits where, a 33-year-old Qian, so he's actually born in about 1910 or so. A 33-year-old Qian is sitting with von Karman and the teacher of von Karman, Ludwig Prandtl, who was a Czech fluid dynamicist. And Prandtl, having, I guess, been in German territory, had worked with the Nazis. And the three of them, this kind of Hungarian-American expat, this kind of young Chinese scientist, and this Czech Nazi fluid dynamicist, who are all kind of basically leading figures in their very narrow niche field, are together on like it's sort of just appreciating each other for a moment, but on this kind of totally like poles apart geopolitical narrative that's about to unfold. And so, yeah, Qian's like a leading scientific figure at this time. And it's also interesting to, I guess, for me that like it's a reminder that pre-1945, at least, like science was, or scientists as a community were seemingly much more political and much more ideologically forthright in various ways than, at least I tend to imagine, the scientific kind of profession now, mostly. And so after the war, in I think around 1948, I definitely have it more accurately in my piece, he starts to be looked into by the FBI, and shortly after that is taken as into house arrest. This is like shortly after, I think, writing co-writing with von Karman a really important post-war reports. Similar to, I think this is under the era of like um, the guy who wrote As We May Think, the post-war science administrator. Ah, okay. Anyway, this is so he's taken under house arrest shortly after he publishes like quite an important report about American air supremacy with von Karman, which becomes like a leading kind of priority during the kind of post-war period. And this is a period where the US is kind of thinking about like what to do with all of our science, all of our kind of like investments in this period of war, and also what to do with all of this technological supremacy that we seem to have gained, and this power that we seem to be kind of like accumulating over a world order, really. And then Qian gets taken to house arrest under the Red Scare, and he basically is in that condition for, I think, at least 4 or 5 years. He was detained in 1950, and he published Engineering Cybernetics, his textbook on ballistics and systems control, in 1954. I think it's only shortly after that he actually returns to China. So he was under house arrest for basically 5 years. And in this time, I think he was asked whether he was a communist. And there are FBI files you can still download on him. And he basically remains sort of neutral. He never gives up his love, I suppose, for China, nor his kind of at-homeness in America. Like he isn't particularly politically aligned in any way. But he is a kind of patriot to his home country, and he is obviously someone who adopted America in a very important way. So as a result, this was has sometimes been considered, maybe rightly, it's hard to judge these things for me, but like one of the most major strategic fuck-ups of the US in the 20th century, really, to kind of like give up one of your top scientific assets to a communist nation that you consider to be one of your top adversaries, and historically will turn out to be your top adversary. So in 1955, he is allowed to return to China along with a couple of other Chinese scientists in a similar kind of condition. And he never looks back. He goes to China and is recognized by the Chinese leadership. This to put a bit more context around this. 1955, People's Republic of China is about 5 years and 2 months old. After the revolution, or the victory of the communists in 1949, it is a basically dirt poor agrarian country that had decades of civil war and conflict with the Japanese. They kind of did civil war, were invaded from Japan, so they quit the civil war for a while and kind of tried to get their shit together, and then that was over and they did the civil war again and the communist one. So this is in quite a febrile kind of period, to say the least. And we're also shortly before these kind of like dramatic mega projects that Mao undertook in the 1950s, the late 1950s, famously in the Great Leap Forwards, which was this gigantic agricultural reform project, which did result in famines, which killed millions and millions of people. But they recognized that Qian was an asset, and they brought him and a number of other scientists, welcomed them with open arms, really. And then, the short version of the story, in a way, is that he goes on to build the fastest nuclear program and the fastest satellite and rocketry and generally kind of Cold War defense technology program, I think, in world history, and as far as it's in 20th century history, of like this Cold War kind of dynamic. So he returns and he immediately gets put in important positions where he immediately starts assembling different kind of ministries and centers and kind of working groups for, amongst other things, cybernetics as well. starts an institute of operations research, which is this kind of adjacent field, which I wonder if you might actually know more about than I do, which emerges in the war as a kind of combination between management and statistics to kind of like understand how to best most like basically optimize production systems and bureaucratic systems, I believe. I think operations research mostly ends up going down into the kind of business school road. But I think initially it was used to kind of like optimize, like arms production during World War II.
Did Chen have any did he have a role in the Great Leap Forward? And I ask because, like, it's often presented as this sort of, canonical central planning disaster. And I'm wondering if he had like a prominent role in some of the initiatives in it.
Yeah, he did have a role. It's a little bit hard for me to judge exactly. Because he had a role in the sense that in that period, in the late 50s and early 60s, he wrote a number of articles, and there were some public articles. He'd already become, I think, this kind of like very significant scientific figure, and also a figure very much part of the state. And he did like publish this one diagram along with an accompanying article about basically reimagining the whole production system of China. This kind of extraordinary diagram that kind of starts with like coal and energy and grain and so on, and ends with like the making of clothing and everyday life, and in the middle is all these kind of different like units and production processes and stuff. So he has this kind of grand vision kind of approach, and by accounts, the number of accounts that I've read, which are mostly secondary sources, to be fair, he's involved, but it's hard to tell just how influential these ideas were. And if they were influential, they did seem extremely ham-fisted and like extremely abstract, like really governing from the center of this huge, unwieldy, complicated country, and imagining it could just be kind of like wired up like a bunch of different units in a control system or something. So it's I guess I really don't know how much to hold them responsible for the disasters of the Great Leap Forward, and I think they are considered like even the most ardent kind of believers in the party would accept that there were mistakes made during that period. And yeah, he was part of the imagination of it, or at least he seemed to contribute to the imagination of it, but it's not clear how much actual influence he had over that kind of thing.
Gotcha. And ultimately, you sort of present the idea of Chinese cybernetics as a sort of a slightly different branch of the tree versus what American aficionados of cybernetics might be familiar with, or Western more generally. Could you say a little bit more about sort of what how does Chinese cybernetics sort of land somewhere different or distinguish itself from the rest of the field?
So very loosely, I guess you have the mainstream of cybernetics in the US. You have Soviet cybernetics, which, to be fair, or Soviet control systems theory, which, to be fair, is also where a number of the people in China who end up in China in the 50s and 60s, who they're trained by, because Qian was fortunate to be one of the kind of like more privileged elites in China in the early 20th century who received a Boxer scholarship and stay in America. But most sort of people who went out to study would have gone to the USSR until the kind of Sino-Soviet split in the late 50s. The Chinese line, I guess the way I think about it, and I have to say this part of this is interpretive, is that the US cybernetics emerges with alongside a superpower in a kind of relatively bourgeois kind of condition. Like it's a it's already a highly developed nation about to reach its real swing into the kind of post-war baby boom era, into kind of like going into the kind of height of American hegemony. And it takes a lot of very philosophical kind of turns. At least the parts of it I've looked more into. Perhaps there's also a lot to say about kind of its influence on engineering, but certainly people like Wiener, Bateson, they understood cybernetics as part of a kind of a worldview, and that was taken much further with like there was a cybernetics magazine, which they're kind of like all watched over by machines of love and grace, and this kind of imaginary of 1960s and 70s, which people like Fred Turner have covered really well. That was part of this kind of whole picture, which did also influence, let's say, American computer culture and cyber culture and all of that stuff. In China, you've got a very, very different picture, because while they might come from some similar roots in terms of engineering and control system design, this kind of thing, in China, you're talking about like really just nation building as like that's the only game in town for people working with the state, for elites and so on. So you're not, I mean, my sense of it is that at least in the beginning, in the 50s and 60s, you're really not interested in this kind of more moral philosophical imagination that people like were kind of interested in. You're really much more interested in building up a defense program, understanding how to maximize production systems, how to organize food, bring people out of poverty, like reconstruct a nation that is breaking up with the Soviets, that is seeing threats from all over, that's just been invaded by Japan and is facing, American Red Scare era threats as well. You're kind of on, I guess, red alert all the time. And so the technological side of that is really about development, of course, like growth, economic growth, and well, actually, that's not quite right. It's economic growth really takes the back seats to the kind of production as such until the 80s. And so, yeah, so I think the distinction, the strong distinction I make, at least I came to in writing this piece, is that on one side you have this somewhat more kind of philosophical approach, and on the other side you have this deeply pragmatic approach, which is how do we construct a modern nation from a kind of the ravages of like civil war and from a recently feudal imperial kind of country into the kind of mid 20th century. And I mean, if the kind of, I guess, historical anomaly of modern China is anything to go by, then like that project, in some ways continues and was kind of if I was going to say a remarkable success. That's kind of probably should qualify that. It was a remarkable achievement of nation building that people like Qian made a huge contribution to, in the form of basically building up the entire defense program, building up the rocketry, satellites, and ballistics and communications program, and building up the kind of state scientific infrastructure in the form of various institutes and so on.
Yeah, I mean, there's something really interesting. I mean, one of the threads that jumps out at me in that line of thought is that there's something very interesting between, on the one hand, imagining cybernetics as developing systems that are subordinated to a nation state, and then on the other hand, developing systems that may not be subordinated to the nation state, that may extend beyond it. So there's something, potentially something a little bit more more unbounded or internationalist in the way of thinking about the economy, for example, in the West, and that has sort of a couple valences to it, right? Like so on the one hand, you can think about that as being somehow more philosophical or more idealistic or less pragmatic. On the other hand, you may think of it as being more naive, right? Or or more like ideological in the negative sense of that word, right? So there's a lot of interesting questions that come up when you think about whether the control systems that cybernetics builds are, subordinated to the nation state or not.
Yeah, that's really interesting and feels quite knotty to me because I think on one hand, yeah, we can think about systems as infrastructures that we live in and amongst and maybe subordinated to and maybe identified more or less with the state and so on, this kind of cybernetic technologies, if you like. On the other hand, there's a kind of, I guess, liberalism versus, in this case, socialism kind of split,
Yeah.
where liberalism might identify the individual against the state, against the kind of administration organization of society, and think about kind of this system of different nodes in a kind of relatively free economy and how they interrelate. And I suppose you could make a link from that to the way in which Western cybernetics was perhaps more psychologizing, more kind of it's cultural anthropological in the sense of like thinking about like relative ways in which different kind of social systems might relate to each other and different individuals, even to the point of the cybernetics of conversation with things like people like Gordon Pask. I mean, it was really applied very much to experience, I guess. Whereas the flip side of that is where you identify control systems, society, and the state together, because society is part of the society is, the state is in the kind of administration of society, which is a sort of reproduction system for itself, I guess. And so that way you would kind of think of nation, i.e. the landmass of China in the case of Qian Xuesen, states, the administration of the social, and people as part of society, as part of one big control system. So whether you have a picture of someone being subordinated or not is kind of more of a philosophical question about whether you value the individual over the social, I guess, in this kind of classic dichotomy.
Right.
And in this case, in Qian's case, I think what becomes kind of interesting and is it sort of fits as part of this idea of how to design a nation, how to design the administration of a number of people who live on a geographic landmass such as China. And those things really link together, like how to administer different forms of production in different parts of the nation, how to like move energy from the energy rich regions to the kind of like economically productive areas, how to defend, like defense, and how to kind of bring infrastructure into the easier to defend center versus the kind of like vulnerable to Japan outside. All of these things. Oh, and also how to control demography, because one of Qian's students, most famously, perhaps as of his legacy as a Chinese cybernetics person, is that his student Song Jian becomes an important scientist and administrator who's responsible for one-child policy. Was one of the early architects of that. So how to administer a demographic and how to kind of like think of society itself as a control system. And all of these things come with massive qualifications to like whether they were good, successful, achieved their goals, etc. But nonetheless, the way of thinking is for all of those things to be collapsed, I think, together, to think of that whole thing as a control system rather than a bunch of different individual people being subjected to different kinds of control.
Well, so just to push back on that slightly, like one,
Mm-hmm.
I mean, so you're sort of describing the whole thing as a control system here. So we've got control systems that are oriented towards particular ends, and then we have the sort of social or political layer, which is part of the stack. But the way that I think about that, and tell me if you think I'm missing something here, is is that actually, if you're taking the sort of discipline of cybernetics and then subordinating it to particular ends, in a way, those ends are defined by a political realm, which is placed sort of outside the domain of cybernetics. Whereas is another way of thinking about cybernetics where you really are applying that kind of thinking to the political realm and thinking that essentially cybernetic processes become create the feedback loops and the dynamics that also define the goals, as well as, implementing the goals, which are defined outside of cybernetics.
Yes.
And my perhaps, naive way of reading what you're saying is that, and this may not be exactly what you're saying, this might just be my projection onto it or something. But, I'm sort of interpreting, I interpret the kind of Silicon Valley ideology that gets layered onto cybernetics as a little bit more of as a kind of a way of collapsing that political realm into cybernetics, as opposed to keeping a sort of a non-cybernetic political decision-making layer above cybernetic systems, the way you seem to be describing Chinese cybernetics.
Yeah, I mean, no, that's really interesting. I'm trying to work out if it's at this hour whether I can quite formulate well enough a kind of response to that. I think it's really interesting because I'm not quite saying that this all is Chinese cybernetics, because I don't think there is a kind of like as clear a discipline or a kind of like narrative of Chinese cybernetics. It's been written about by myself and a number of other people, and there's about to be a book actually with about China and AI, which will have a number of good pieces on it. But this, where you can draw a line around the kind of number of people and ideas and like phenomena that could be classified under Chinese cybernetics, I think you find a much more heterogeneous set of ideas, not like heterogeneous from each other, but like a much more kind of mixed amalgamation of different ideas than you do with maybe what you're describing with a kind of Silicon Valley idea, like kind of a totalization of cybernetics, kind of feedback loops, free informatic feedback loops, or something somehow as the kind of like the apotheosis of what is good and true of all systems. I think this is maybe again it's where this kind of pragmatism comes in. Like for someone, at least in for some of his ideas, someone like Qian I don't think he ever proposed that like let's say governments or various other of these systems should be run via cybernetics. He did come up with things like expert systems and like kind of various imaginations for like new ministries or like kind of decision-making processes, which would rely on like, informatic processes being pulled at that speed here, like expert consultation here, political governors kind of taking all this here, and these kind of much more mixed methods kind of systems. And to the extent that I think perhaps a kind of cartoonish way to put it would be that if the kind of caricature of the Silicon Valley relationship turns cybernetics into a kind of morality and a kind of ontology for how all complex systems work. In Qian's case, it was much in the Chinese case more broadly. It was much more of a set of like different ways to apply mostly mathematical thinking to complex social issues. So in a way, it was like, rather than how can we subject cybernetics to the political, is like, how can we make the political scientific again? How can we make kind of like social policy scientific? And what do we mean by scientific? We mean like the application of various kind of like statistical kind of methods and like operations research kind of optimization methods and so on. But it's not clear to me that at the heart of all those were like automatic feedback loops that would like take governance out of the picture, whether as a kind of a theological point or just simply as a practical one. A lot of it was really about optimization, and I think Qian, maybe at one point, I think he says something like he defines himself not as an engineer, but like as a applied scientist, basically, and his science being the field of cybernetics, which he wants to apply to lots of other things. But I think if you look at one-child policy and you look at like Chinese infrastructure policies and like the ways in which the kind of movement of energy and movement of kind of technological like production centers are organized as part of a kind of overall national system, geographically and spatially, what you see is like a kind of a sort of systems logic being applied at quite a macro scale in just quite practical kind of ways of like almost someone kind of drawing a diagram of the country or something, to solve mostly quite practical problems, such as fear of invasion and like producing more coal or something.
Yeah, fascinating stuff. This is a really rich conversation. I wish we had a little bit more time to continue it. But for those who are interested, hope they'll check out your piece. And super grateful that you contributed it to Combinations. So thank you for that. And thanks for this great conversation too.
Yeah, thanks, Matt.
Thanks again to Matt Prewitt and Gary Zhang. If you'd like to delve deeper into the fascinating world of Chinese cybernetics, be sure to check out Gary's insightful piece in Combinations magazine. Combinations is a new publication exploring the intersection of technology, power, and society. This issue features pieces by Rana Das-Gupta, Glenn Weil, Joseph Weiler, Christina Liu, and more. It's a must-read for anyone interested in the future of technology and culture. You can find it online at combinationsmag.com. The Radical Exchanges podcast is produced by G. Angela Corpus, co-produced and audio engineered by Aaron Benavides, and executive produced by G. Angela Corpus and Matt Prewitt. It's hosted by Matt Prewitt, with additional audio provided by me, Combinations editor Guy McKinlittle. If you want to learn more about Radical Exchange, please follow us on X at RadExchange or check out our website at radicalexchange.org. Have a great day and stay radical.